In this video, I'm going to explore more how to graph some transformations of our tangent, cotangent, secant, and cosecant graphs. And we're going to start out with a tangent graph. A cotangent example is going to be very similar. So I'll note how if this were a cotangent instead of a tangent, how things would change. Let's say we wanted to graph something like y equals 2 times the tangent of 3x plus pi. So if you remember back when we did this with sines and cosines, we have a vertical scaling by this multiplication by 2. We have a horizontal scaling given by multiplication by 3. And we have a horizontal shift where we're adding pi. So I like to do these problems a little bit differently than how we were doing the sine and cosine graphs. So the first thing I'd like to do is think about what the period of a graph like this is going to be. So remember, for sine and cosine, if we're multiplying x by some number b, the period was 2 pi divided by b. Now, for the tangent graph, recall that the period is pi. So when we're doing tangent or cotangent, the period is pi instead of 2 pi. So now the period is going to be pi divided by b. In other words, the period of this tangent graph is going to be pi over 3. This isn't necessary because when we graph our vertical asymptotes, we're going to find that anyway, but it's sort of a nice way to start. All right, now let's think about where two of our vertical asymptotes are going to be. So remember, for the tangent graph, the vertical asymptotes occur where the cosine is equal to 0, since tangent is sine over cosine. In other words, when our angles are coterminal with pi over 2 or 3 pi over 2, so along the y-axis on the unit circle, our tangent was undefined, we had vertical asymptotes. Okay, now we're not taking the tangent of x, so now we don't want the cosine of x to be 0. We're taking the tangent of 3x plus pi. So we want the cosine of 3x plus pi to be undefined. So the way we would say this is, again, thinking about the tangent graph, we had vertical asymptotes at negative pi over 2 and positive pi over 2. Those are the ones that were around x equals 0. So now we'll have vertical asymptotes when 3x plus pi is equal to negative pi over 2, and when 3x plus pi is equal to positive pi over 2. So that's going to be two of our vertical asymptotes. This is going to give us what's sometimes called the principal cycle for the tangent graph. So these are going to be where the vertical asymptotes that would ordinarily be at plus and minus pi over 2 get shifted. So again, we have these horizontal scalings and translations, and these two vertical asymptotes are going to shift somewhere else, and these equations will tell us where they're going to go. Okay, so in other words, we just take whatever is inside the tangent, and we're going to set those equal to plus or minus pi over 2. Okay, so when we do that, we're going to have 3x equals negative 3 pi over 2. So we're going to subtract pi from both sides. Negative pi over 2 minus pi is negative pi over 2 minus 2 pi over 2 is minus 3 pi over 2. And then we divide through by 3, and we get x equals negative pi over 2. Okay, so actually, that first vertical asymptote stays at minus pi over 2 in this case. Okay, now looking at 3x plus pi equals pi over 2. We do the same thing. Okay, we start by subtracting pi from both sides, so we can solve for x, and we get 3x equals negative pi over 2. And then divide both sides by 3, we get x equals negative pi divided by 6. Okay, so if we take a look at our graph, if we draw one period of our new tangent function, we can have one vertical asymptote at negative pi over 2. okay, and 1 at negative pi over 6. So those are the boundaries of our so-called principal cycle. And if we check the distance between negative pi over 2 and negative pi over 6 is going to be pi over 3, which is our period. So just an observation there that that distance is going to be 1 period. Okay, so now we want to plot some points to actually get our tangent graph in between those two vertical asymptotes. And if you remember back to our discussion of the graph of the tangent function, there are 3 points in each period that we can look at. There's a point that is halfway in between the vertical asymptotes, and then there are points that are halfway in between each vertical asymptote and that middle point. So I'll start by figuring out where that middle point is. And it's going to be halfway in between negative pi over 2 and negative pi over 6. So what we can do is take the average of negative pi over 2 and pi over 6. Okay, so we can do that by adding negative pi over 2 and negative pi over 6 together and then dividing by 2. Okay, so that's going to be negative 3 pi over 6 minus 1 pi over 6 divided by 2, or negative 4 pi over 6 divided by 2, or negative 2 pi over 6, which is negative pi over 3. In other words, halfway in between negative pi over 2 and negative pi over 6 is negative pi over 3. Okay, and we'll see in a minute that that does make a certain amount of sense. Okay, so that would be our x-coordinate. And then the y-coordinate of our point we could find by plugging our x into our tangent. So we're going to take 2 times the tangent of 3 times negative pi over 3 plus pi. And it's going to be 2 times the tangent of negative pi plus pi is 2 times the tangent of 0, which is 0. Okay, in other words, there's going to be a center point at x equals negative pi over 3, y equals 0. Okay, so now let's find the 2 points that are halfway in between that center point and our vertical asymptotes. And I'll start with the one on the left-hand side. Okay, so now we want the x value that is halfway in between negative pi over 2 and negative pi over 3. Okay, and we can find that by averaging those two values. Okay, so now we want x to be negative pi over 2 minus pi over 3 divided by 2. Okay, so that's going to be negative 3 pi over 6 minus 2 pi over 6 divided by 2, or negative 5 pi over 6 divided by 2 is negative 5 pi over 12. And then the y-coordinate is going to be equal to 2 times the tangent of 3 times negative 5 pi over 12 plus pi. Okay, so now we're going to plug in x equals negative 5 pi over 12. Okay, so that's going to be equal to 2 times the tangent of 3 over 12 is 1 over 4. So this is going to be negative 5 pi over 4 plus pi is 4 pi over 4. Okay, or negative 2 times the tangent of negative pi over 4 is 2 times negative 1, or negative 2. So we'll have a point at x equals negative 5 pi over 12, y equals negative 2. And then our last point we'll look at is the one that's in between x equals negative pi over 3 and x equals negative pi over 6. Okay, so we'll do the same sort of thing. Okay, so now to find the x coordinate, we're going to take the average of negative pi over 3 and negative pi over 6. So we add those two together, divide them by 2. So that's going to be negative 2 pi over 6 minus pi over 6 over 2. And it's going to be negative 3 pi over 6 divided by 2. Okay, or negative pi over 2 divided by 2 is negative pi over 4. Okay, so our last point here will be at negative pi over 4 equals x, and then to find the y, we're just going to plug that into our tangent. So we'll have 2 times the tangent of negative 3 pi over 4 plus pi over 4, or sorry, not pi over 4, pi, which is 4 pi over 4. So negative 3 times pi over 4 plus 1 pi. Okay, so that's going to be 2 times the tangent of pi over 4. Okay, negative 3 pi over 4 plus 4 pi over 4 is 1 pi over 4. Okay, and the tangent of pi over 4 is 1, so we're going to have 2 times 1 is 2. Okay, so we're going to have our last point at x equals negative pi over 4, y equals 2, and then we connect these with a tangent graph curve, and that's what one period is going to look like. And then if we wanted to, we could just copy and paste this over and over and over again to get more periods. But this is what we would call the principal cycle, because we got the vertical asymptotes by setting 3x plus pi equal to plus and minus pi over 2. Okay, now a couple of observations about this. First being that we can use, instead of using this method, the same method we used for sine and cosine if we wanted. And that is, our period is pi over 3, so if you take a quarter of that period, it's going to be pi over 12, pi over 3 divided by 4. And if we started at the leftmost vertical asymptote and kept adding pi over 12, we would get negative 5 pi over 12, negative pi over 3, negative pi over 4, and eventually negative pi over 6. So we can find the x-coordinates of these three middle points by adding quarters of the period the same way we did to find the quarter points of sine and cosine graphs. So you can work through it that way if you want. I tend to just take averages because I just think it's a little bit easier to do than to add fractions together, but you can certainly work through it that way as well. One other observation I want to make is if instead of a tangent, this was a cotangent. So remember, for a cotangent graph, we had vertical asymptotes at 0 and pi. Okay, so now if instead of a tangent we were doing a cotangent, we would take the stuff inside the cotangent, set it equal to 0, set it equal to pi, and then solve for x. And that would give us the x values of the new vertical asymptotes. And then you'd work through the problem the same way as we did here, find the points in the middle, plot them, and then connect the dots. Okay, so in the next video, we'll talk about how to do the same sort of thing with a secant and cosecant graph.